This is Mech 330 Programming for Industry 4.0. We're going to be rolling dice, and so we're going to, from random, import random int. This is something built in with Python. So we're going to make a class called die, and we're going to call how many sides that our dice has as our default. 6 is our default here. And then we're going to actually roll the dice here with this function. And this is going to be between a number between 1 and how many sides that the dice has. So the first thing that we're going to do with this class is plot 2 histograms based off of 2 6-sided dice. So we're going to first call our class here, and that's going to be die 1. And then we're going to call our class again as die 2. And we put the number 6 in here. Its default is 6, so I didn't necessarily have to do that, but I did it for testing purposes. So then we're going to actually roll the dice here. We're going to be rolling it 1,000 times here, so in the range of 1,000. And then we're going to actually take the dice roll from number 1, dice roll, dice, and dice roll 2, and we're going to then append those together into result, and then we're going to append that to results. So then down here, we're going to take actually an empty list called occurrences, and this is going to be for storing the number of occurrences of the 2 dices. And we're going to then take those 2 and put the number of sides together. So the number of sides, this would be, in this case, 6. This would be 6. So we're putting those together into a variable called max sum. And then we're going to look how many times that a number occurs. So the lowest number that we have is 2. So in the range of 2. And then the highest number that we're going to have is 12 plus 1. So then we're going to see how many these times these numbers occur and store them into occurrences. And then down here, we're going to take those results that we found from occurrences, and we're going to visualize them with a graph. So this first stores each possible result from 1 to the max number you can roll. And you must convert whatever range into a list using this list right here. And instead of the example, we put in max sum here, a variable, instead of what it was before, which was just after that, bar is a class in Plotly that unlocks bar graphs, needs 2 arguments, x and a y. And instead of frequency, I put in occurrences here. This is just the labeling of the bar graph right here. Must be a key value pair. Same with this one, must be a key value pair. I kept frequency here for, viewer. And then this right here from Plotly returns an object that specifies the layout and configuration of the whole, has the title of the graph, and pulls the key value pair of x and y axis. I just slightly adjusted the string to 2 d6s 1,000 times. And then this here plots the graph, a function that takes a dictionary containing the data and layout objects in the file for where the graph will be saved, which will be saved as an HTML file. So I'm going to build, and then here comes this graph. And as we can see, 158, 161, 224, 48. So we see that there's 1,000 values there. So the second task for the class from die is to roll first a d6 and a d10. So it could be anything, anything really that was 2 different dice. So all we had to do is put 10 in here from the class. And then we're going to make a function here. And this is necessary for the 2 different rolls that we did. We did 50,000 and 100,000. So we needed to make a function here. because the total roll number is going to be a variable. And then the roll number here is also going to be a variable. This is very similar otherwise as the first program. Same with occurrences. Creates an empty list for storing the number of occurrences. Same stuff. We do it all the way the same up until we come down here where we're going to make this right here the number of roll times a variable. So we needed to use an F string. And we also need to do that for the number of roll times in the file name, because we're going to be making two files when we're plotting. So when we're doing our offline plot here. Otherwise, other than that, we just call the two functions that we made, 50,000 and 100,000. And then we get our result of two graphs. And I can see that I have some string changes I can make real quick. Oh, wait, no, that's right. Yeah, that looks good. Okay, so yeah, and we can see that the graphs are slightly different for the two, just slightly. Um, it seems like the trend is the same between the two, but other than that, thank you for watching.